welcome everyone. My name is Botaji Aman. I am a PhD student at Farhat Abbas University City 1. I will be presenting our work education with artificial intelligence, survey and AI-generated student essay reflection. Here's a brief overview of what we'll be covering today. We start with an introduction and some background context, then move on to the adoption of AI writing tool in education. Next, we will discuss current AI detection methods, followed by the challenges and limitations of these methods. And finally, we will conclude with key takeaways. Let's begin with the introduction. The intersection of education and artificial intelligence is causing a fundamental shift in academic settings. Generative AI technologies, including powerful models like GPT-4, Gemini, and Llama, are challenging traditional assessment methods. AI systems can now produce essays that are coherent, contextually relevant, and stylistically sophisticated. This capability is disrupting traditional education practices that rely heavily on written assessments. Essentially, the ease with which essays can be generated raises fundamental questions about the future of how we evaluate student learning. The ability of machines to generate human-like text has evolved through several strength phases. Earlier rule-based systems could produce simple responses but lacked general language understanding. Later, statistical approaches using Engram models and hidden Markov models enabled the generation of more coherent text. The neural revolution, with the advent of recurrent neural networks and long short-term memory networks, marked a significant leap, allowing for the generation of more coherent long-form text. Finally, the transformer architecture revolutionized natural language generation, laying the groundwork for the large language models we see today. These transformer models utilize attention mechanism to effectively capture long-range dependencies within text. The scaling of these models directly resulted in significant improvements in text generation capabilities. Contemporary models can now generate essays that closely mimic human writing across a wide range of academic disciplines. Written assessments have long been a cornerstone of education assessments. They provide critical evidence of student learning, the development of critical thinking skills, and mastery of subject matter knowledge. Academic integrity frameworks are in place to address various forms of misconduct, with plagiarism being a key concern. Plagiarism detection tools like Turing were an initial technology responses to ensure academic integrity. However, AI writing tools disrupt this landscape by enabling students to generate original content that can bypass traditional plagiarism detection methods. This creates what we term the authenticity problem, where the generated work is technically original but does not genuinely represent the student's own thinking or writing abilities. The release of ChatGPT in November 2022 marked a watershed moment in the accessibility of AI writing tools. Large percentage of the students report using AI writing assistants for academic tasks, including essay writing. Educational responses to these tools have varied, with some institutions implementing bans and others focusing on AI literacy and redesigned assessments. Many institutions have modified their academic integrity policies in response to generative AI. The detection of AI-generated student essays is a critical frontier in education technology. Current approaches to identify machine-authored essays can be categorized in 4 paradigms. The first is telemetric analysis, We have statistical metrics, we have machine learning models and deep learning models, and we have hybrid systems. The first paradigm, stereometric analysis, focuses on identifying differences in writing style between human and AI-generated text. These methods analyze a range of features, including sentence complexity, vocabulary diversity, and punctuation and formatting patterns. Tools like GLTR utilizes stereometric analysis by visualizing the predictability of word choice. Linguistic feature analysis is a related approach that examines textual characteristics such as lexical diversity and syntactic complexity. The second paradigm involves statistical and linguistic metrics. These metrics quantify textual properties that help differentiate between human and machine authored text. Key metrics in this category include perplexity and entropy, which measures how surprised a language model is by a given text. Burstiness, which evaluates variation in sentence length, is another important metric. Additionally, semantic coherence is considered as AI models may sometimes produce semantically inconsistent statements. Frameworks like DetectGPT leverage these statistical metrics by comparing the log probability distributions of text under different perturbations. The third paradigm utilizes machine learning and deep learning models. Supervised learning approaches train classifiers on labeled datasets of human and AI-generated essays. Traditional machine learning models, such as support vector machines, random forest, and gradient boosting, have shown moderate success in this area. Deep learning architectures, including convolutional neural networks, recurrent neural networks, and transformer-based models, are also employed. Transformer-based models, fine-tuned specifically for detection tasks, currently represent the state-of-the-art in this category. It's also worth noting that hybrid systems, which combine multiple methodologies, are being explored to enhance robustness. The fourth paradigm consists of hybrid and ensemble approaches. As mentioned, hybrid systems combine multiple methodologies to achieve greater robustness. Feature fusion is one such technique, integrating telemetric, statistical, and deep learning-derived features into a unified classifier. Adversarial training involves training detectors on AI-generated text that has been intentionally perturbed to evade detection, making the detectors more resilient. Ensemble models deploy voting systems where NLP-based classifiers, statistical analyzers, and deep learning models collectively determine authorship, leveraging the strength of each approach. In response to the growing need for AI detection, several commercial and open source tools have emerged. Commercial tools like Turnitin AI Detector and GPT-0 are examples of hybrid frameworks. Specialized detection platforms include GPT-0, Turnitin AI Writing Detection, and Originality.io. These platforms typically integrate multiple detection methodologies and provide user-friendly interfaces for educators. Importantly, detection tools are increasingly being integrated directly into learning management systems to streamline the workflow for educators. It is crucial to acknowledge the challenges and limitations associated with AI-generated essay detection. These can be broadly categorized into technical challenges, ethical concerns, and practical barriers. Technical challenges include the ability of adversarial evasion techniques like text humanization, the use of multiple AI systems sequentially, and the use of multiple AI systems sequentially, and control paraphrasing to circumvent detection. Poor model generalization across different domains and languages, the rapidly evolving capabilities of AI and the occurrence of both false positives and false negatives are also significant technical hurdles. Ethical concerns include privacy issues related to analyzing student writing, equity problems such as potential bias against non-native speakers, the chilling effects that detection tools might have on legitimate AI-assisted learning, and the lack of transparency and accountability in the detection systems themselves. Practical barriers involve the high computational costs associated with some detectors, particularly transformer-based models, and integration challenges with the existing educational workflows, the absence of standardized evaluation benchmarks for comparing different detection tools, and the perpetual arm race between AI generation and detection capabilities. In conclusion, AI technologies have fundamentally disrupted traditional assessment methods in education. Detection technologies offer promise, but face significant limitations. As we have discussed, addressing both the technical and ethical complexities requires interdisciplinary solutions, bringing together experts from various fields. Critical research gaps remain, including understanding the impact of these technologies across diverse student populations, examining the longitudinal effects on learning outcomes, and developing ethical frameworks specifically tailored to educational contexts. Ultimately, AI in education presents both challenges and opportunities, and navigating this evolving landscape effectively requires synergy and collaboration between researchers, educators, and policymakers. Thank you for your attention.